Welcome to the House of Maths. Today I'm going to be looking at solving a quadratic graphically. The last one I did, the quadratic was a positive here, so it was a U-shaped quadratic. This one, remember when the negative is here, you're going to get a curve that goes that way. So that's what we're looking at here. Here's a typical sort of setup where you're given the equation and you're given a little table to fill in some missing points on it. So we've got some of the y values, but we've got two spaces missing. So we've got to find out what goes in here, and then we're going to plot it on our graph. So remember, what we do is we take the x value and we substitute into the x in our quadratic. So let's start with this one. So I'm going to put -3 where I see x. So if I write -2, and I'm going to substitute in there -3. Like so. So I've substituted that in. You've got to be careful with the signs here. So remember, -3 squared is -3 times -3, which is 9. Times -2 is going to give you -18. Now for the next term, we've got -6 times -3. So a minus times a minus is going to give us a positive. So that's going to be +18 plus 5. So you can see that these two cancel each other out, and we're just left with 5. So that's going to go in there. Now we're going to put our 2 in. So we've got -2, and I'm substituting in 2 this time. And then I'm just going to work out what these are. So 2 squared is 4 times -2 is -8. -6 times +2 is +12 plus 5. So what have we got here? -8 and 12 is 4, plus 5 is 9. Okay, so now we can plot our points. So we've got -4 in the x direction and -3. So -4 along, -3 is about here. Now notice I've not got graph paper here, so I'll do the best I can, but this would be on graph paper in an exam and you could plot it exactly. So -3, 5, plus 5, -3 there, plus 5 is about there, -2, 9, -1, 9, 0, 5, 1, -3, going to be about there, and then 2, 9. Right, what's happened there? That looks wrong, doesn't it? Okay, if we're thinking about what the curve looks like, it surely should be here. This point up here looks a little bit dodgy, doesn't it? Looks like I might have done something wrong. So if you get a situation like that where you've got a point which doesn't look quite right, you're maybe going to have to go back and look at what you've done. Okay, so let's just check again what I did with that 2. So I put 2 in here. 2 squared is 4 times -2 is -8. Oh, look what I've done here. -6 times +2 is -12, not +12. So I made a mistake here, didn't I? But the good thing is when you plot it, you can see that there's a mistake. And if you know that when you've got this coefficient here, -2x, and you obviously know it's a quadratic, you know you're going to get a curve like that, and it's going to be a parabola, and it's going to be symmetrical about the axis here. So you know that that's what that curve is going to look like. When this anomaly crops up over here, you should immediately think, I've done something wrong, okay? And then go back and check your work and find out what you've done wrong. And as you can see, I got a positive there instead of a negative. So now that I've corrected that, I can change that value over there, can't I? So I've got minus 20 plus size minus 15 is what I want over here. So I'm going to go 2 along minus 15, which is going to be way down here. And that's starting to look a little bit better now, isn't it? So if I join up these points as best I can, and that's going to go off down there. So there's our curve. Couple of things to mention here. It is a curve. Don't join these up with straight lines. That would be incorrect. And also, this bit here, clearly, it's going to, if it's going to be a curve, it's going to bulge up a bit here. Don't just go straight across there like that. That would not be correct. So in this case, the maximum point is going to be somewhere above 9. You could complete the square on this to find out where that is. If you want to know how to complete the square, check out one of my earlier videos on that, and you'll see how to do that. So we've now filled in our 2 missing spaces in that chart, and we've plotted our quadratic. What tends to follow next are questions getting you to look at and interpret this graph you've got here. So you could get a question that looks like this. Okay, so we've got exactly the same quadratic, so it's this curve, and we want to know where it equals 4. So all you would do is take your ruler, and what we're basically saying here is this bit here is our y. This bit equals y. So we're saying y, in effect, equals 4, positive 4. So we're just going to get our ruler, draw the y equals 4 line, and our solutions would be where the y equals 4 line crosses the quadratic. And again, on your graph paper, you'd be able to read these off a lot more accurately than I can do off my board here. Remember, in the exam, these points here, there will be a range of values. So, you know, if you're not exactly spot on, you should be okay. If you're way off, then you will have a problem. But so long as you work as neatly as you can and draw this curve as accurately as you can, you should be within the range that they require. Okay, so that's a fairly straightforward type of question. You could also get something a little bit harder. So I'm just going to rub that line across there out. You could get this equals something like that at the end. But obviously this is a little bit more complicated. Now you could solve it algebraically by shifting these terms back over to this side, and then you could factorize this or complete the square, or even use a quadratic formula. But as we've got a graph here, what you're going to be expected to do is solve it graphically. So you're going to need to put this onto the graph. Now hopefully you can spot what this is. It's the equation of a straight line. Now you should know that the equation of a straight line is of the form y equals mx plus c, where m is the gradient and c is the intercept on y. Okay, so what it's telling you is that we've got a gradient of 2, and this line crosses the y axis at 1. So we know that it's going to go through that point there. So I'm going to put that one on there. Now there are 2 ways you could go about drawing this line. You could say, well, it crosses at 1, but it's got a gradient of 2. So a gradient of 2 basically means that for every 1 that you go across, you're going to go up 2. So you could go across 1 and up 2, go across another one and up 2, go across another one and up 2, and you get a straight line, and you could then get your ruler and plot that. Or you could alternatively use the table that you've got up here and extend it down a little bit. So I'm just going to use the positive values here because they're the easier ones to put in. So I'm going to put these positive values in here. So that 0 is going to go in here. So 2 times 0, 0, plus 1 is 1. So when x is 0, we get 1. If I put 1 in here for the next value, 2 times 1 is 2, plus 1 is 3. So when x is 1, y is 3. And then if I put 2 in, 2 times 2 is 4, plus 1 is 5. So when x is 2, y is 5, which is basically, that's 2 along, 5 up. That's 3 along, 7 up. So I've got some points here. And then I can take my ruler. Once you've got at least 3 points, you know, you're going to know you're right. Don't do it with 2 points, because if you've got one wrong, you could make a mistake. If you've got 3 points and they're all in a straight line, then you know you're okay. And then you can put your ruler through that. And oops, that's gone a bit badly astray. And it's going to go over here somewhere. Okay, so your solution is going to be where it crosses here and where it crosses just there. And then you can read those off the graph. And again, if you draw it accurately, you'll be okay with the mark, getting the marks. There'll be a range of values, and hopefully you'll be within that range. So there's a quadratic solved graphically, and I've gone on and added a little bit more of a complication at the end, where you've got to set this quadratic equal to this straight line and plot these points on to work out where they intercept. I mean, there's no reason why this couldn't be another curve which you've got to plot on there. It's quite possible that could happen as well. Okay, so I hope you enjoyed that. If you did, remember to hit the like button. More content coming soon.